This week I interviewed for a faculty position in anatomy and physiology at a liberal arts college in Michigan. It would be the perfect job for me, and it would begin next fall. Hope is a dangerous thing, but I think I've gotten by on hope for decades. I worry that if I knew 20 years ago everything that I know now about the life I would lead, I would be reluctant to carry it through. Nobody enters college with the expectation that they will be starting their career 20 years later. And you know what? That really does seem to be how long it takes. Sure, I could have shaved 2 or 3 years off given the practical advice of my future self. When I was 20, I had an associate's degree and was looking to transfer into a 4-year biology program. I found out that there were prerequisites that I still needed to complete before I could enter the university. I would still have to do them, just as I did. I would be about 23 when I completed my bachelor's degree. I would do reasonably well in terms of my GPA and test scores, but I couldn't go directly to graduate school, just as I didn't the first time around. I would need to join a lab as a technician, to learn to carry out research, to make every mistake possible before becoming proficient. I'd get into the PhD program perhaps 2 or 3 years earlier, since I would have sought out a technical position immediately upon finishing my undergraduate studies. I might choose a different research project in graduate school, knowing how unsuccessful my experiments would turn out to be. But hell, there would have been other problems and other failures to take place of the originals. It would take me 6 years, give or take, to defend my dissertation. Then I'd do a postdoc. Maybe this time around I would switch to a focus on teaching earlier in the process, after say 3 years rather than 5. But then again, the COVID pandemic delayed my projects, and if it hadn't, well then maybe I would not have had the time at home to smash my head against the problem of consciousness on an almost full-time basis, to work on this podcast, to publish the TICL. I'll tell you what, I'll decide whether I would do it again once I know how it all turns out. Wouldn't that be convenient? We have a new research paper to talk about. It's called Quantifying Arousal and Awareness in Altered States of Consciousness Using Interpretable Deep Learning. It has a lot of authors, so I'll call it Minji, Lee et al. The authors distinguish between 2 components of consciousness, which they identify as arousal and awareness. Arousal refers to the level of wakefulness. Awareness refers to having subjective experiences. Arousal and awareness co-occur under normal conditions when we are awake and going about our business. However, during a state of vivid dreaming, we are clearly not awake, and we don't respond to moderate stimuli coming from the environment, but we are certainly aware. We are aware of the dream experience. Some of the authors on this paper have shown up on the podcast before. In particular, I told you about Marcello Massimini and Giulio Tononi's studies, which combined EEG with transcranial magnetic stimulation, or TMS. This technique of recording EEG from the scalp while delivering a magnetic stimulus is called, handily enough, TMS EEG. EEG is a useful technique for distinguishing between deep sleep and wakefulness, but for decades REM sleep, which is often associated with dreaming, has been considered paradoxical because the brain waves revealed by EEG are almost indistinguishable from normal waking brain waves. Massimini and Tononi developed a measure of the level of consciousness called the Perturbational Complexity Index, or PCI. The perturbation is the magnetic stimulation. The researchers are perturbing the cortex. The complexity has to do with how the EEG responds to the stimulus. They found that the response during normal wakefulness or during REM sleep was significantly more complex than that which occurred during non-REM sleep or under anesthesia. The Perturbational Complexity Index was a decimal value, quantifying how simple or how complex the EEG response was. Once they had established the index, they applied it to comatose hospital patients and used it to successfully distinguish between those who would report having been aware while they were in a coma and those who would make no such report. In other words, they could tell which patients were experiencing locked-in syndrome. The new study, reported in Nature Communications, utilizes the TMS EEG protocol to go even further. The authors applied it during waking and sleep, under general anesthetic drugs, and in brain-injured subjects. Their data were analyzed using machine learning to separately determine arousal and awareness. Previously, with the Perturbational Complexity Index, they could not tell the difference between a state of wakefulness and one of dreaming, or between a normal waking state and a state of anesthesia induced by ketamine. These states of awareness showed the complex response. By contrast, they saw the simple response in non-REM sleep, vegetative state, and under general anesthetics like propofol. In that study, they found a cutoff at 0.31 psi. Below that was unaware, and above that was aware. Here, with the added power of deep learning, the authors report the capacity to distinguish among states high in arousal and awareness from states low in arousal, but high in awareness. Since the technology they are using allows the authors to distinguish the correlates in brain activity, they call the new index the ECI, or Explainable Complexity Index. This approach makes it possible to find correlates of awareness which are separable from correlates of arousal. Excellent. Lee et al. Write, quote, TMS EEG responses under sleep exhibited well-known phenomena. In wakefulness, TMS generates a series of low-amplitude, high-frequency activities related to cortical flow in long-range connections. A similar long-lasting response is evoked during REM sleep with subjective experience. During non-REM sleep with no subjective experience, TMS triggers larger, low-frequency activity that quickly dissipates, which is the hallmark of bistability in the thalamocortical system. Cortical effective connectivity is also broken down during non-REM sleep. The brain response to TMS perturbation was already used to distinguish the levels of awareness, irrespective of sensory processing and motor responses under physiological, pharmacological, and pathological conditions. Therefore, this TMS-evoked response was applied to our end-to-end convolutional neural network framework. Similar to several studies using machine learning, we observed higher two-class, low or high, classification accuracy using the convolutional neural network when compared to linear discriminant analysis and support vector machine for both arousal and awareness. This suggests that our framework is especially relevant for EEG results, which possess several nonlinear features. The classification performance of spatiotemporal information was higher than that of spatiospectral information. Using our framework, it was shown that temporal information discriminates different levels of consciousness more clearly than spectral information, as the functional connectivity associated with consciousness changes in both space and time." Unquote. Damn right it does. This is just the beginning of a new frontier using machine learning and other computational methods for discovering the fundamental correlates of consciousness within the complexity of thalamocortical brain activity. The authors report a main finding in the parietal cortex, in agreement with earlier studies. They write, quote, "In sleep and healthy wakefulness, when arousal and awareness were high, they were highly relevant in the parietal region. This EEG feature, which distinguishes high and low states in arousal and awareness, can be interpreted in line with the posterior hot zone of consciousness. Local changes in this parietal region are associated with the occurrence of dreaming and unconscious sleep, and our framework may learn from EEG pivotal features recorded in this area. The importance of the posterior hot zone has already been emphasized using the within-state sleep paradigm. Similar to sleep, we observed high relevance scores for the parietal region in the domains of both anesthesia and patients with disorders of consciousness. This implies that EEG activity in this region had a decisive effect in determining the high and low states of arousal and awareness. The increased slow wave activity was observed under propofol and xenon-induced anesthesia when compared to healthy wakefulness before drug administration. In addition, just as cortical neurons induced bistable changes during non-REM sleep, TMS in propofol-mediated anesthesia induced low-amplitude, low-frequency, positive-negative potentials, and TMS in xenon-mediated anesthesia caused a significantly large amplitude but stereotyped positive-negative deflection. Moreover, under ketamine-induced anesthesia, TMS-evoked responses was determined to be similar to REM sleep, which features dreaming during a low state of arousal. Previous studies have shown that the change in slow waves induced by propofol is primarily observed in the posterior hot zone, and the posterior main hub is disrupted during anesthesia-induced alteration of consciousness." Unquote. The posterior cortex seems to be sufficient for experience itself. The frontal cortex is necessary for voluntary movement, executive function, and attentional processes. This seems to be where the will meets the world. Passive experience, simply being aware of something without engaging or reporting, takes place, it would seem, posterior to the frontal lobe. It can be difficult to dissociate this because, in general, we only know whether a subject has seen something or heard something, for example, when they report it to us by telling us what they see, or pressing a button, or fixing their eyes on something. All of these movements and actions implicate the frontal cortex and confound the correlates of consciousness. Machine learning, though, might be able to disentangle this as well in future studies. Here, I would like to continue thinking about these two components of consciousness described by Lee et al. In their new paper, they talk about arousal and awareness. We discuss subjective experience all the time. That is really the purpose of this podcast. But what about arousal, simple wakefulness? People speak of being conscious and unconscious all the time. And in that context, they're referring to being awake or asleep. Wakefulness, however, for our purposes, is a related but different phenomenon than consciousness, and is much less mysterious. I mean, it's essentially no different than when I move the mouse on my laptop and it wakes up, or when a Roomba suddenly becomes animate and vacuums the floor. It's a state change, but a perfectly objective occurrence. Christof Koch does a nice job of talking about the mechanisms of arousal in the brain in his book, The Quest for Consciousness. Koch writes, quote, "In a series of landmark studies in the late 1940s, Giuseppe Maruzzi and Horace Magoon demonstrated that a large region of the brainstem known as the midbrain, or mesencephalic reticular formation, controls the level of arousal or wakefulness in animals. It has also been called the ascending activation system. Direct electrical stimulation of this multifaceted and complex structure arouses the forebrain. The cortical EEG changes abruptly from the slow, high-amplitude synchronized waveforms characteristic of deep sleep to the fast, low-voltage, desynchronized activity typical of the wakened brain. Arousal occurs in the absence of any sensory stimulation. Bilateral lesions of the mesencephalic reticular formation, destruction of one side is typically insufficient, cause the animal to be unresponsive to even intense sensory stimulation. In patients, damage to this area of the brainstem is associated with stupor or coma," unquote. We've seen that patients in a coma can be in a locked-in state, wherein they are having conscious experiences but are unresponsive. This state cannot easily be distinguished by doctors from a vegetative state in which there is no awareness at all. This is one of the great achievements of the Perturbational Complexity Index, to make this distinction. Koch writes, quote, "The locus ceruleus, a compact mass of 10,000 or so neurons on each side of the pons, contains more than half of all noradrenaline-releasing cells in the brain. To make up for their small number, ceruleus neurons broadcast their information widely. A single axon branches profusely and might reach many areas, including the frontal cortex, thalamus, and visual cortex. During the rapid eye movement part of the sleep cycle, the time when most dreams occur, these noradrenergic cells are silent, or almost so. Their level of activity increases as the animal wakes up and becomes especially prominent during situations that demand extreme vigilance and fight or flight reactions. Nevertheless, because the intense dreams that are so characteristic of REM sleep are consciously experienced, though usually not consciously remembered, the lack of noradrenergic input to the cortex during dreams would rule out noradrenaline as part of the enabling factors of the NCC. If a single neurotransmitter is critical for consciousness, then it must be acetylcholine. To rigorously establish this claim is difficult, however, because the synaptic release of acetylcholine, called cholinergic transmission, is widespread, occurring in the distal periphery, where motor neurons contact muscles, and centrally, deep in the cortex," unquote. In the central nervous system, acetylcholine release fluctuates with the sleep-wake cycle, with increased activity during waking states and during REM, but lower activity during slow-wave sleep. Koch argues that acetylcholine is a critical enabling factor for consciousness, while norepinephrine is apparently necessary for a state of arousal, but it doesn't track with awareness. Arousal is, I believe, a red herring when it comes to the correlates of consciousness. Whether an animal, or indeed a robot, is active and engaging with its environment tells us nothing about whether it is having an experience. The subjective experience is the mystery of consciousness, the hard problem. In fact, In a world of zombies, such as that proposed by David Chalmers, there is no question that the postulated zombie would wake up and go about its business, drinking coffee and answering emails and driving cars, then go to sleep at night. These imposters, though, would do all of that without having thoughts or feelings or sensations, without dreaming. In his book, The Conscious Mind, Chalmers writes, quote, "The most obvious way to investigate the logical supervenience of consciousness is to consider the logical possibility of a zombie, someone or something physically identical to me or to any other conscious being, but lacking conscious experiences altogether. At the global level, we can consider the logical possibility of a zombie world, a world physically identical to ours, but in which there are no conscious experiences at all. In such a world, everybody is a zombie. So let us consider my zombie twin. This creature is molecule for molecule identical to me, and identical in all the low-level properties postulated by a completed physics, but he lacks conscious experience entirely. To fix ideas, we can imagine that right now I am gazing out the window, experiencing some nice green sensations from seeing the trees outside, having pleasant taste experiences through munching on a chocolate bar, and feeling a dull ache sensation in my right shoulder. What is going on in my zombie twin? He is physically identical to me, and we may as well suppose that he is embedded in an identical environment. He will certainly be identical to me functionally. He will be processing the same sort of information, reacting in a similar way to inputs, with his internal configurations being modified appropriately, and with indistinguishable behavior resulting. He will be psychologically identical to me. He will be perceiving the trees outside in the functional sense, and tasting the chocolate in the psychological sense. All of this follows logically from the fact that he is physically identical to me by virtue of the functional analyses of psychological notions." Unquote. He goes on to say that there will, however, be no phenomenal feel. There is nothing that it is like to be such a zombie twin. The Chalmers thought experiment was intended to show that such a world, one without consciousness, could be conceived of and compared with our own reality. Such a world would exist just like ours in every objective sense, or so the argument goes. It's a purely behaviorist world, inputs and outputs, cause and effect, straight determinism. And oddly, the argument implies philosophers would still write books like The Conscious Mind by David Chalmers, still puzzle over the hard problem of consciousness in their conversations and in articles, even though the philosophers themselves were not having subjective experiences of any kind, and no one ever did. This, to me, is outrageous, but that really is the view that must be held if consciousness is an epiphenomenon. In the zombie world thought experiment, everything is precisely the same, but without this inconvenient little side effect known as consciousness. In the natural case, it seems perfectly reasonable that creatures could come to act as we do in response to the same environments by means of a different biological architecture and a lot of natural selection. The likelihood of this happening, given the possibility of consciousness as a constituent of the chain of causality in our universe, is probably low. In order to do what we do, sans consciousness, I think it would take a brain of much, much larger magnitude, just as it takes a larger hard drive and processor to store and run a modern video game compared with a 1980s arcade classic. Likewise, I suspect it takes 1,000,000 times more steps for facial recognition software to identify a face than it does for the human brain. This is the great power of awareness, the most fascinating mystery of which I'm aware.